We have been a verticalized expert in the manufacturing space for the last 5 years. We have been doing AI long before AI was considered a cool product. Overall, we aim to look at all different steps within manufacturing, starting from inventory. Inside inventory, we have inward management, we have warehousing, we have binning, kitting. Then we have the MES system where the manufacturing happens, where the assembly line operations happen. We then have pre-delivery inspections, warehousing, logistics, then delivery and paperwork of the finished goods. We also do a detailed audit of all different types of softwares ranging from ERP systems like SAP, Oracle, up to standard cloud hosted ERP systems. We also look at MES systems, we look at QMS systems, we look at WMS systems across a full spectrum of manufacturing challenges. Overall, what we have identified is currently there is a big gap between tech and manufacturing, where tech people are not used to the efficiency and the lean way of manufacturing implementations. We aim to bridge that. We do not recommend very expensive and high quality instrumentations and sensors to be installed for our AI systems to work. We start with very simple concepts like using mobile cameras, mobile apps, portable tablets, and cameras to detect various stages of the assembly line. Our value proposition ranges from building computer vision applications to automated document filling to optical character recognition, OCR systems. And overall, we aim to digitize the full manufacturing plant and promote manufacturing so that efficiency gains can be translated to on ground factory level, production level metrics. We have an engine block which is wired through all different types of connectors. You have the fuel lines, you have the exhaust lines, you have the electrical lines, you have various electrical spark plugs and multiple lines wired into the engine so that everything runs smoothly together. Now, in such kind of test, the engine is run at various RPMs. It is run at static RPMs. It is run at gradually increasing, decreasing, varying RPMs. Throughout this, a very sustained test load is simulated about how this engine would perform in a real life example. Based on this testing load that is simulated, we would then be able to understand how this engine is performing. We then look at how the engine has performed, create a testing report, and then it can be decided if the engine is going to pass or the engine is going to fail. Throughout this process, we have implemented multiple AI systems that can help you do all of this in a much more streamlined and efficient way. Before we do that, let's look at how the workflow is before an AI system is implemented. Currently, there have to be a lot of pressure monitoring lines. There have to be a lot of humans involved in the process, and there has to be various type of dyes, various type of colors in between the water, coolant, oil, fuel lines which are running across the engine. It is extremely important to look at drops in the pressure, to look at changes in measured values, to look at overall equipment efficiency, and to look at overall operational efficiency, to look at fuel consumption, to look at broad level RPM, and how is the response time with regards to changing RPM within that engine. The way we do this through AI is extremely simple. Aligning with our core ethos of not relying on very expensive hardware and very expensive use cases, what we do is extremely simple. We have multiple mobile phones and we use mobile cameras based on those smartphones. These cameras are then pointed to various stages in that engine block. For some cases, we look at the water lines or the coolant lines. These lines have to be dyed in a particular color, but then you have smartphone cameras that are zoomed in on those lines. Based on this, it can detect if there is a leak in real time, even before this leak hits the ground. Next type of sensors, which are again smartphone cameras, are then zoomed in on various key sensors. Let's say operating temperature, let's say chamber pressure, let's say piston timing modules. Such sensors are closely monitored through a single smartphone camera frame. In this frame, we analyze what are the sensor values. These sensor values are compared to what is the base level accepted nominal test values, and then a subsequent test report is generated. The third feedback loop which we use is in the same smartphone camera system, we also utilize the microphone system, where we look at various repeated noises of these engine blocks. What we do is we kind of analyze and implement a concept called Fast Fourier Transform, where every audio bit is then broken into its core constituent frequencies. These frequencies resonate and map to various resonant frequencies of various engine blocks. Based on the magnitude or based on the amplitude of these resonant frequencies, we can understand if the engine is working at a normal capacity or not. We have our own patented and our own proprietary audio and image analysis algorithms. And through a combination of audio analysis, image analysis, vibration analysis through accelerometers, a single smartphone has capacity to work at par, if not better than a lot of multi-million dollar sensors. The only catch is we have to be very efficient with building AI software that can integrate with all of these sensor datasets together. As an engineer, it is my dream to make sure that all of the efficiency gains through AI are translated down to the lowest level of manufacturing, where all sorts of efficiency gains can net be used towards improving the productivity, profit margins, and subsequently economics of a manufacturing plant. Please reach out to us to implement such advanced solutions within your factory. We are here to help. We offer free assessments, we offer free trials so that we can build solutions that are ROI aligned and can subsequently benefit in massive long-term growth potential.